Question 1, Part A. We are given a graph. We have point A, point B, and a value of 1. We also have point O and a radius r. We are given that the perimeter of the shaded region is 12. We need to find r. The perimeter is equal to r plus AB. Therefore, 12 equals 2r plus AB. This is our equation 1. We know the angle is equal to the arc divided by the radius. Given that the angle is 1 is equal to the arc AB divided by the radius r. From this, we get that r equals AB. Using equation 1, 2r plus AB equals 12. Substituting r for AB, we get 2r plus r equals 12. Simplifying 3r equals 12, so r equals 4. This is our final answer. Question 1, Part B. We need to calculate the value of theta. Theta is equal to 2 pi minus the angle AOB. Given that angle AOB is equal to 1, we have theta equals 2 pi minus 1. Now let's find the area of the non-shaded region. The area of the non-shaded region is equal to 1/2 multiplied by theta multiplied by r squared. Substituting the values, we get area equals 1/2 multiplied by 2 pi minus 1 multiplied by the value of r, which is 4 squared. This simplifies to area equals 1/2 multiplied by 2 pi minus 1 multiplied by 16. Next, we divide by 2, resulting in 8. So, the area becomes area equals 8 multiplied by 2 pi minus 1. This is our final answer. The question of the two positive integers n and n plus 1 show that the difference of their squares is equal to the sum of the two integers. Now, the sum of the integers is equal to n plus 1, which equals 2n plus 1. The difference of their squares equals to n plus 1 squared minus n squared equals n plus 1 plus n multiplied by n plus 1 minus n, where a square minus b square equals a plus b multiplied a minus b is equal to 2n plus 1. Multiplied by 1 is equals to 2n plus 1. So proved it the difference of their squares is equal to the sum of the two integers. This is our final answer. Question 3 of the part A. Show that the equation 2 cos squared x plus 5 sine x equals 4 may be written in the form 2 sine square x minus 5 sine x plus 2 is equal to 0. Let's start by considering the equation 2 cos square x plus 5 sine x is equal to 4. We know that the formula cos squared x plus sin squared x equals 1. So cos squared x equals 1 minus sine squared x. Put the value of cos squared x in equation. So we have 2 times 1 minus sine squared x plus 5 sin x equals 4. Expanding this, we get 2 minus 2 sin squared x plus 5 sin x equals 4. Now let's bring everything to one side to form a standard quadratic equation. 2 sine squared x minus 5 sin x plus 4 minus 2 equals 0. 2 sine squared x minus 5 sin x plus 2 equals 0. And this is our final answer. Question 3, part B, given that equation 2 times cosine squared x plus 5 sine x equals 4, where 0 is less than or equal to x less than or equal to pi. So we have 2 times cosine squared x plus 5 sine x equals 4. We know that cosine squared x is equal to 1 minus sine squared x, substituting this into the equation. 2 times 1 minus sine squared x plus 5 sine x equals 4. This simplifies to 2 minus 2 sine squared x plus 5 sine x equals 4. Now we'll rearrange the equation. So 2 sine squared x minus 5 sine x plus 2 equals 0. We can factor this equation as follows. 2 sine squared x minus 4 sine x minus sine x plus 2 equals 0. Now we take common factors. 2 sine x minus 2 minus 1 sine x minus 2 equals 0. Next, we factor out the common term. Sine x minus 2 times 2 sine x minus 1 equals 0. Now solving for sine x, if sine x minus 2 equals 0, then sine x equals 2. However, since the sine of any angle cannot be greater than 1, this case has no solution. Next, if 2 sine x minus 1 equals 0, then sine x equals 1 over 2. The sine of x equals sine pi upon 6, so x equals pi upon 6, and sin x equals 1 over 2. The sine of x equals sin 5 pi over 6, or x equals 5 pi over x6. X equals pi over 6, or 5 pi over 6. So this our final answer. Question number 4. Given x plus k to the power of 7 k belongs to the set of real numbers. The coefficient of the term x is to the power of 5 is 63. We know that x plus a to the power of n is equal to n choose 0 multiplied by x to the power of n multiplied by a to the power of 0 plus n choose 1 multiplied by x to the power of n minus 1 multiplied by a to the power of 1 plus n choose 2 multiplied by x to the power of n minus 2 multiplied by a to the power of 2 plus n choose 3 multiplied by x to the power of n minus 3 multiplied by a to the power of 3 plus so on. Now x plus k to the power of 7 is equal to 7 choose 0 multiplied by x to the power of 7 plus 7 choose 1 multiplied by x to the power of 6 multiplied by k plus 7 choose 2 multiplied x to the power of 5 multiplied by k to the power of 2 plus 7 choose 3 multiplied by x to the power of 4 multiplied by k to the power of 3 plus 7 choose 4 multiplied by x to the power of 3 multiplied by k to the power of 4 plus 7 choose 5 multiplied by x to the power of 2 multiplied by k to the power of 5 plus 7 choose 6 multiplied by x multiplied by k to the power of 6 plus 7 choose 7 multiplied by x to the power of 0 k to the power of 7. Substituting the values of the combinations we get, x plus k to the power of 7 is equal to multiplied by x to the power of 7 plus 7 multiplied by x to the power of 6 multiplied by k plus 21 multiplied x to the power of 5 multiplied by k to the power of 2 plus 35 multiplied by x to the power of 4 multiplied by k to the power of 3 plus 35 multiplied by x to the power of 3 multiplied by k to the power of 4 plus 21 multiplied x to the power of 2 multiplied by k to the power of 5 plus 7 multiplied by x multiplied by k to the power of 6 plus multiplied by k to the power of 7. The coefficient of x to the power of 5 is 21 multiplied by k to the power of 2. So 21 multiplied by k to the power of 2 is equal to 63. Dividing 63 by 21, we get k to the power of 2 is equal 3. Taking the square root on both sides, k is equal to plus or minus the square root of 3. This is our final answer. Let's go over question 5, part A. We are given that the function f of x equals log x squared minus 16 for x greater than 4. A diagram is provided with points labeled point B, L, F, point A at A0. This is x-axis, and this is y-axis. Here x equal 4. Point A's coordinates are A0, and the y-coordinate equals fx equals, which is log x squared minus 16. The coordinates of point A are A0, where the y value is 0. We know that 0 equals log a squared minus 16. The value of log 1 is 0. So log 1 equals log a squared minus 16. This implies that 1 equals a squared minus 16. A squared equals 17, so a equals plus or minus the square root of 17. And that is our final answer. Let's look at question 5, part B. We are given that the gradient of the line L is 1/3, and we need to find the value of x, given that for the function f of x is equal to the logarithm of x squared minus 16. First, let's differentiate f of x with respect to x. The derivative denoted as f dash x is equal to d by dx of the logarithm of x squared minus 16. Using the chain rule, we have f dash x is equal to 1 divided by x squared minus 16 multiplied by d by dx of x squared minus 16. Next, we differentiate x squared minus 16 with respect to x, which gives f dash x is equal to 2 times x minus 0 divided by x squared minus 16. This gives us f dash x equal 2 times x divided by x squared minus 16. Now we know that the gradient of the line L is 1/3, so we set f dash x equal to 1/3. This gives us 1 divided by 3 equals 2x, divided by x squared minus 16. To get 6 times x is equal to x squared minus 16. The equation x squared minus 6 times x minus 16 is equal to 0. To solve this quadratic equation, we can factor it as x squared minus 8 times x plus 2 times x minus 16 is equal to 0. Grouping the term x multiply x minus 8 plus 2 multiply x minus 8 is equal 0. Factoring out the common factor x minus 8 multiply x plus 2 is equal 0. This gives us two possible solutions. X minus 8 is equal to 0. X is equal to 8. X plus 2 is equal to 0. So, or x is equal to negative 2. Because x greater than 0. We discard the negative value and are left with x is equal to 8. Thus, the x-coordinate of point B is 8. This is our final answer. Question number 6 is based on the diagram which shows triangle ABC. In triangle ABC, we are given that side AB is 10, side BC x, and side AC 2x. We are given that side AB is equal to 10, side BC is equal to x, and side AC is equals 2x. It is also given that the cosine of angle C is equal to 3 divided by 4. We know that according to the B trigonometric identity, the square of cosine of angle C plus the square of the sine of angle C is equal to 1. Substituting the values we get, which is 3 divided by 4 squared plus the square of the sine of angle C is equal to 1. Therefore, the square of the sine of angle C is equal to 1 minus 9 divided by 16. The square of the sine of angle C is equal 16 minus 9 divided by 16. The square of the sine of angle C is equal to 7 divided by 16. Now taking the square root on both sides, question number 6 is based on the diagram which shows triangle ABC. In triangle, next, using the formula for the cosine of an angle in terms of the sides of a triangle. And again, the cosine of angle C is equal to the square of side B plus the square of side A minus the square of side C divided by 2 times side A times side B. Substituting the values, the cosine of angle C is equal to the square of 2x plus the square of x minus the square of 10 divided by 2 times 2x times x. Since the value of the cosine of angle C is given as 3 divided by 4, we equate. 3 divided by 4 is equal to 4x squared plus x squared minus 100 divided by 4x squared. Cross-multiplying and simplifying, 3x squared is equal to 5x squared minus 100. 5x squared minus 3x squared is equal to 100. 2x squared is equal to 100. X squared is equal to 50. Taking the square root on both sides, x is equal to 5 times the square root of 2. Now we move on to calculating the area of triangle ABC. The formula for TRAIR. The area of triangle is equal to 1 divided by 2 times base times height times the sine of angle C. Substituting the values, area is equal to 1 divided by 2 times 5, the square root of 2, times 10, the square root of 2, times sine of angle C. Area is equal to 1 divided by 2 times 50, times 2, times the square root of 7 divided by 4. After both side 2 by 2 canceled, simplifying, area is equal to 50 times the square root of 7 divided by 4. The area of triangle is equal 25 square root 7 divided by 2. This is our final answer for question 7, part A. A graph is provided where the values range from 0, 10, and so on up to 80. On the other side, the values range from 2, 4, and continue up to 24. These values represent frequency denoted as F and the number of hours is provided. According to the question 40, the maximum cumulative frequency is 80 and the median of the cumulative frequency equals 40. So for 40, the median number of hours equals 14, which is our final answer. In question 7, part B, we are given that 10% of this year's 12 students spend more than 10% of 80 students. 80 multiplied by 10 divided by 100. Canceling out the zeros we get is equal to 8 students. Next, the cumulative frequency is equal to 80 minus 8, which gives us 72. The cumulative frequency (72 in 18 hours). So K is equal to 18. This is our final answer. In question 7, part C, we're given a situation where the number of hours denoted as H spent doing homework falls within different ranges. H is greater than 2, but less than or equal to 7, and frequency is 4. H is greater than 7, but less than or equal to 15, and frequency is P. H is greater than 15, but less than or equal to 21, and frequency is 16. H is greater than 21, but less than or equal to 24, and frequency is Q. Based on the problem, we know that when H equals 15, the frequency is 60. Also, when H equals 7, the frequency is 4. So to find P, we subtract the frequency at H equals 7 from the frequency at H equals 15. P equals 60 minus 4, which gives us P equals 56. Next, when H equals 24, the frequency is 80. To find Q, we calculate Q equals 80 minus 60 plus 16, which simplifies to Q equals 80 minus 76, resulting in Q equals 4. And that's our final answer. In question 7, part D, according to the given information, we need to spend more than 15 hours. For this, our equation is 16 plus Q, where Q is equal to 4, which we determined in part C of question 7. So 16 plus 4 equals 20. So given, there are 320 students in year 12 at this school. So the fraction is 20 over 80 multiplied by 320 students. Simplifying this is equal to 80, because estimate the 20 student out off 80. So estimate the 80 student out off 320. This is our final answer. Question 7E has first part. According to the question, indicates that only Year 12 students were surveyed. Or the amount of homework might be different for different year levels. The second part of this, according to the question, should include stratified sampling or survey students in all years. This is our final answer. In question 8, part A, we are given the diagram of function f with points A and B and axes labeled as x and y. The first part asks us to find the coordinates of points A and B. We are given the f of x equals 6 plus 6 times cos x. F of x equals 0. We set 6 plus 6 times cos x equals 0. This simplifies to 6 times 1 plus cos x equals 0. So 1 plus cos of x equals 0. Cos x is equal minus 1. Cos x is equal to cos pi. X is equal to pi, and cos x is equal to cos 3 pi. Because x is equal pi plus 2n multiplied by pi. X is equal to 3 pi. X coordinates of A and B, pi and 3 pi. This is final answers for the coordinates of points A and B. Question number 8, part B. We need to find the area of the shaded region, which is given by the given by the integral from pi to 3 pi of f of x dx, is equal to the integral from pi to 3 pi is where the value of f of x is 6 times of 1 plus cos of x dx is equal to, we have 6 times the integral from pi to 3 pi of 1 plus cos x dx, which equals 6 times x plus sine x, evaluated from pi to 3 pi. The area is equal to 6 times 3 pi minus pi plus sin 3 pi minus sine pi. So the area, simplifies, is equal to 6 times 2 pi plus 0 minus 0. The area of the shaded region is equal to 6 multiplied by 2 pi, which equals 12 pi. This is our final answer. We are working on question number 8, part C. In this problem, we have a diagram of a cone. Here h represents the height L, represents the slant height, and the radius is given as 2. We are also given the total surface area of the cone is equal to 12 times pi. R is equal to 2. To start, we know that the formula for the total surface area of a cone is equal to by the radius squared plus pi r L. Now we substitute the values into the formula. Given that the area is equal to 12 times pi is equal to pi multiplied by radius squared plus radius multiplied L, substituting the radius value into the equation, we get 12 equals 2 squared plus 2 multiplied by L. This simplifies to 2L equals 12 minus 4. Further simplifying, we get L equals 8 divided by 2, which gives us L equals 4. This is our final answer. Our question is part D of question number 8. Hence, find the volume of the cone. We have a diagram of a cone where the radius is equal to 2, the slant height, L, is equal to 4, and we need to find the height, h. We know that the formula for the slant height squared L squared is equal to the height squared, h squared, plus the radius squared, r. So h squared equals L squared minus r squared, which means h equals the square root of L squared minus r squared. Given that L equals 4 and r equals 2, we can substitute these values into the equation. So h equals the square root of 4 squared minus 2 squared, which simplifies to h equals the square root of 16 minus 4, giving us h equals the square root of 12. Simplifying further, h equals 2 times the square root of 3. Now the volume of the cone is given by the formula volume equals 1/3 times pi times r squared times h. Substituting the values, we have the volume V equals 1/3 times pi multiplied by 2 squared multiplied by 2 times the square root of 3. Simplifying this, V equals 1/3 times pi multiplied by 4 multiplied by 2 times the square root of 3, which gives us V equals 8 times the square root of 3 divided by 3 times pi. Finally, V equals 8 divided by the square root of 3 times pi. This is our final answer. The question 9 part A, we're given the function st equals 8t minus t squared for 0 less than or equal to t less than or equal to 10. Now we'll draw the graph with s on the vertical axis and t on the horizontal axis. Find the value of p when t equals p and s of t equals 0. So we start with the p equation, 8t minus t squared equals 0. We can factor this equation as t multiplied by 8 minus t equals 0. This implies that either if t equals 0, then we have one solution. If 8 minus t equals 0, then t equals 8. Therefore, at t equals p, the possible values of p equals are 0 and 8. This is our final answer. Question number 9, part B. The first part is to find the value of q. The vertex of the parabola is given by s of t is equal to 8t minus t squared. Setting s of t equals 0, 8t minus t squared equals 0 can be factored as t times 8 minus t equals 0. If t is equal to 0, or 8 minus t equals 0, then t equals 8. When t equals q, the particle changes direction. So q is equal to p divided by 2. Thus, q is equal to 8 divided by 2, which is 4. Now, for the second part. According to the question, when t is equal to q, and given that s of t is equal to 8t minus t squared, we put t equal to q equal to 4. S of 4 is equal to 8 multiplied by 4 minus 4 squared, which simplifies to 32 minus 16, which equals 16. The displacement of the particle from the origin is 16 units. When t is equal to q. This is our final answer. The question we have is the C part of question 9. According to the question, when t equals 10, given that s of t is equal to 8t minus t squared. At t equals 10, s of t is equal to the absolute value of 8 times 10 minus 10 squared. So s of t equals the absolute value of 80 minus 100. Therefore, s of t equals the absolute value of negative 20, which gives s of t equals 20. This is our final answer. Our question is part D of number 9. According to the question, we need to find the value of d when t equals 0, t equals 4, and t equals 10. So, given that the function s of t is equal to 8t minus t squared, so when t equals 4, s of 4 is equal to 8 multiplied by 4 minus 4 to the power of 2. This simplifies s of 4 equals 32 minus 16. Therefore, s of 4 equals 16. When t equals 10, s of 10 equals the absolute value of 8 multiplied by 10 minus 10 to the power of 2. This simplifies to s of 10 equals the absolute value of 80 minus 100. S of 10 equals the absolute value of negative 20, which is 20. Now, S of 10 equals the absolute value of 20. We calculate the total backward distance. The total backward distance is equal to 16 plus 20, which equals 36. The forward distance is equal to 16. Finally, the total distance is equal to 36 plus 16, which equals 52. And that is our final answer. Given question number 9, part E, we need to find the value of k. given that Vt is equal to 14 minus 2t, where t is greater than or equal to 0. Let's start by setting v at t equal to 0. So 14 minus 2t equals 0, which simplifies to 2t equals 14. Therefore, t equals 7. We know the total distance is equal to 52. So we can set up the equation as is the integral from 0 to k of Vt dt, which equals the integral from 0 to 7 of 14 minus 2t dt, plus the integral from 7 to k of 2t minus 14 dt. Substituting the values, we get 52 is equal to of 14t minus 2t squared divided by 2 from 0 to 7, plus 2t squared divided by 2 minus 14t from 7 to k. Simplifying further, 52 equals 14 multiplied by 7 minus by 7 squared minus 0, plus k squared minus 14k minus 7 squared minus 14 multiplied by 7. This simplifies to 52 equals 2 multiplied by 49 minus 49 plus k squared minus 14k minus 49 plus 2 multiplied by 49. Continuing with the simplification, we get k squared minus 14k plus 98 minus 52 equals 0, which simplifies to k squared minus 14k plus 46 equals 0. Now comparing with the standard quadratic equation, ak squared plus bk plus c equals 0. We see that a equals 1b equals minus 14 and c equals 46. Using the quadratic formula, k is equal to minus b plus or minus the square root of b squared minus 4ac divided by 2a. Substituting the values, k equals minus 14 plus or minus the square root of minus 14 squared minus 4 multiplied by 1 multiplied by 46. All divided by 2 multiplied by 1. This simplifies k equals 14 plus or minus the square root of 196 minus 182 divided by 2. Further simplifying, k equals 14 plus or minus the square root of 12 divided by 2, which simplifies to k equals 14 plus or minus 2 times the square root 3 divided by 2. K is equal to multiply 7 plus minus squared root 3 upon 2. Finally, k equals 7 plus or minus the square root of 3. This is our final answer.